Traditionally, JavaScript has been a procedural and/or functional programming language. However, with ES6, some new syntactical features were released that enable us to write JavaScript in a more object-oriented manner. We may not always use object-oriented programming when writing JavaScript, but understanding the principles of object-oriented programming, or OOP, is an important step in becoming a developer. Object-oriented programming is most commonly used throughout the industry. It's the most commonly used methodology of how to write code. It may seem difficult at first, but it is actually how we as humans already interact with objects in real life. Objects have attributes that define them and things they can do. For example, let's take a look at a DVD player. Some of the attributes a DVD player has might include height, weight, the width, and the color of the DVD player. And some of the functionality that it might be able to do would be play a DVD, fast forward, rewind, and pause. Together, these attributes and functionality make up the description of this object, the DVD player. We can say how tall it is, what color it is. We know it can do this functionality. That, when we build that out in code and then have a different object like a DVD that has its own attributes and functionality, they can interact together and we can modularize our code to make it more effective. A DVD player interacts with other objects as well that have their own attributes. Like I said, a DVD. And some of the attributes for a DVD could be the movie length, the image, and the size. Right? When we think of the things we are programming as individual objects that can interact with other objects, we can start to shape our code in a more maintainable way using OOP. OOP offers a lot. The four main pillars of object-oriented programming are abstraction, encapsulation, inheritance, and polymorphism. Abstraction allows us to hide complexity by giving us a 30,000-foot view of a concept or object. For example, an abstraction for vehicles would be the fact that they all move. Every vehicle may move differently. Planes fly, cars drive, boats float and sail, but they all move. That is abstraction, taking the concept of motion and saying a vehicle moves. Encapsulation is hiding the details of how a method works. An example is when you drive a car, you don't know exactly what the engine's doing, and you don't have to know that in order to be able to drive. The functionality has been encapsulated so that we as users, don't have to worry about it. We just have to know how to drive, not what's going on under the hood. Inheritance is probably the concept we're most familiar with already. Just as we inherit traits from our parents and our ancestors, object-oriented programming inheritance allows objects to inherit properties and functionality from other classes. A parent class or a base class can pass its properties or functionality down to another class that inherits from it. Polymorphism is the last of these four core pillars of object-oriented programming. And polymorphism means that something can take many different forms or multiple different forms. For example, an animal communicates differently from another animal. So we have the abstraction of animal, but depending on what type of animal it is, communication, that functionality would be different. A dog barks, a cat meows, and a bear growls. All are instances of an animal communicating, but the communication method is polymorphic, based on which animal is performing the action. Aside from these four pillars of object-oriented programming, we need to learn how to structure our code so that we can use it in an object-oriented fashion. We can use constructs called classes to group our code together in a logical way to represent objects. In fact, objects can be created from classes. You can think of classes like blueprints for objects to be created from. And then an object is an instance of a class. You'll hear the terms object and instance used interchangeably, and that's because they're so similar, because an object is an instance of a class. You have your blueprint of houses, and you create a bunch of houses from it. The blueprint is still just a blueprint. It's not a house. But the house is an instance of that blueprint. We're not going to go over in this video how to create classes. That's going to be in one of the following videos.